Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are doing some Z-buffer work. I've already explained it all and we started to make the changes for it. And we probably would have been done with the changes this past weekend, except we took last weekend to do some catch-up streams that had been scheduled for a while. One was a mock interview with Sean McGrath that we were supposed to do, and we did that. And the other was a Handmade Con 2016 follow-up with Charles Bloom, and we did that. Both of those were really cool. If you haven't checked them out, you should check them out on the Handmade Hero YouTube channel. But now we are back to programming, and so let's just go ahead and dive right back into it. I should open up, where's my Milton at? I should open up my Milton in case we need to draw some things. Let's go ahead and close that off, and let us open up our project. Today is day 460, so if you're following along at home, you want to open up day 359 source code and start with that. That is where I'm starting with. So let's go ahead and get the project open and building. Now, if you remember correctly, since we've switched over to the Z-buffer, now we are in sort of limbo. Our old sorting is not going to work anymore. And we haven't quite gotten to the point where the Z-buffer stuff is enabled. So if you run the game, it's just a flash-a-thon, right? Everything's going nuts. And everything's always in the right place, and the game is functioning as it should, but the sorting is completely haywire. And that's exactly what we expect to happen, so that's not unusual, but it's just worth pointing out that that's where things are at. So obviously our goal is to return our game to like a stable appearance, but using the Z-buffer instead of sprite sorting, which is what we were doing before, that is now disabled. So if we go to render group, remember what we were sort of doing is slowly sort of moving the projection operations that we had here in get render entity basis p, and we were slowly moving them over into OpenGL, and we already have done a little bit of that work. So let me grab that here. Here you go. We already have done a little bit of that work because we had this sort of notion of this OpenGL screen space here that we were using. And before we had a bunch of stuff in here that wasn't really relevant that we could basically fold into the OpenGL screen space operation. And what we were doing prior to our changes in OpenGL set screen space was sort of undoing stuff that we had done in get render entity basis p. And in some sense, this is work that we probably should have done anyway, because it makes more sense to have this stuff in the actual render layer than it does to have it in the code that just pushes things onto the render stack. Probably, you know, it's 6 of one, half dozen the other, but it just makes more sense to have it that way because it gives you more flexibility in the render backend. It's a little bit more bookkeeping, but and we'll kind of see that happen a little bit later on. But in general, like, it kind of is nice to kind of move this stuff over because that way the renderer backend can use the full horsepower of whatever it is operating with. So in the case where you have a software backend, well, it really doesn't matter because software has to do the transforms like it would have in either place. But when it's using a hardware backend, you can offload that work onto the GPU, which is, in a game like this, exactly what you want to do, since you know you have a lot more GPU power than you need for the typical 2D game these days, right? GPUs are set up to run something like Battlefield 1, and so when you're throwing something like Handmade Hero at them, you know they have more than enough horsepower. You're not in a situation where you have to be thinking about, should I try to keep some of the work on the CPU so that I, you know, don't use up more GPU resources that I need for some other thing, right? So just being aware of that, it's like good to kind of have it so that the render layer can have that ability to offload work to the GPU because we know we've got the horsepower there. So the more stuff we can push over there, the more CPU we free up for doing stuff like gameplay. And in this case, we know pretty much that we're not going to stress out a GPU with something like Handmade Hero because we're not trying to produce like photorealistic 3D graphics or something like that where, you know, you might start to get concerned and need to do things on the CPU side for whatever reasons. All right. So here we are in get render entity basis p, and what you can see here is we've still got this meters to pixels concept going on here. And really the meters to pixels concept at this point I think could probably be retired. All it really is a scaling factor right now. That's it. It doesn't really do anything else at all. And so if we take a look inside the camera code, right, and we look at where meters to pixels is getting set, it's just a scaling factor for the game now. That's all it is, because everything has been transformed, is in world space now and being operated on that way. And we don't really need that meters to pixels transform for anything in particular, right? It's just sort of an arbitrary idea of how we want to scale the game, but we can just set the camera's distance to be greater or less than based on that. And it doesn't really matter in one way or the other, because it's just an extra multiplicative factor, right? It's just something that cancels out the z a little bit. So we don't really need that factor for anything in particular anymore. And we could just decide to get rid of it, right? We could just decide that it's superfluous and we don't actually need it. Let me go ahead and grab where we're setting it here. Let's see. I guess that's in our camera. Let's see. Here we go. So when we set this in code, right, we're setting these meters to pixels. Where is our perspective call? Don't know where it is here. Let me see where we're calling that. Looks like it's right here. So you can see us doing this, I think, in get standard camera parameters probably is where we're doing it. So get standard camera parameters. Oops. Why could I not find this? Get standard camera params. I typed out parameters. All right, so if we take a look at this function here, you can see us doing sort of a nominal computation in order to get this scaling factor here, right? So we've got this world scale concept. If we were to just say that the only camera param was going to be the focal length, right, and we just don't scale the world anymore by anything in particular, we would end up with something that looks like this. Everywhere that we were using the world scale, would just go away. And so I'm just going to take a look at what happens if we remove that entirely, right? So everywhere that we had been passing the world scale, that goes away, and we're just left with just the focal length. And then we take a look at those calls where we've got orthographic and perspective happening. And if we take a look at the other thing too that you'll notice is the only place we use orthographic is for our debug UI. And when we call that, you'll notice we don't even use the meters to pixels transform because we were just using screen space there, right? So if we take a look at what's actually happening there, and we go to those functions, and we remove meters to pixels entirely, so it doesn't need to get passed anymore, like so. Now we just have to remove it from this function, and that's about all we should have to do. So we take a look here. We are multiplying it. This was just previously only ever a 1 anyway, so there was no actual operation of the meters to pixels there. Here we would get rid of it as well. And then let's see where else we've got it. Here it is. So that just goes away. Same with it. This is the unprojection here. So obviously anything that we were doing in the projection had to be unprojected. Here we've gotten rid of it. So now we don't need to do that anymore. Are we using monitor half dim in meters for anything either? Let's see here. Monitor half dim in meters. Just curious where that's being used at the moment. So it's being used here where we want to do our fit distance to half dim, right? And get camera rectangle at distance, right? So basically we're using that monitor half dim in meters. We're using that because we need to know how big the screen is, right? And I feel like we could rewrite these two routines to be agnostic and just use the transform that we know we're doing with the screen area. So I think we could get rid of this as well. So because that's just going to be a function, the pixels to meters. We should be able to figure out how to do that just from using our transform alone, using the focal length and so on. Isn't this focal length supposed to be... oh, right. This focal length does get passed in the perspective, but not in this one. So in the orthographic case, we can do this trivially because we basically know... we basically know that this is the size of the screen always, right? The size of the screen is always going to be the pixel size, because the orthographic operation doesn't actually change this at all, right? The pixels to meters is not relevant here at all, right? So, you know, monitor half dim in meters and the screen center are the exact same thing in this case, right? Because we just have half the screen length in pixels is going to be half the dimension. There's no difference there. We don't have to convert anything because pixels are the actual unit at that point, so we're good to go. So the only thing that's a little confusing is what we do under the perspective transform in terms of doing pixels to meters. And again, right now, the only place we're actually using any of that is when we look back at when we try to do things where we imagine what is the like in the world, what is the area that the monitor can basically see, right? And that's what we needed it for. So in order to do that, we just need some way of getting rid of this and figuring it out in reverse. We don't necessarily have to do that now, but we'll have to put that on our to-do list. I also am interested in if screen center gets used, because I don't think it does either. Yeah, you can kind of see that it really doesn't get used much. It's only for reverse. It's exactly the same thing, only for reverse projection. Right, you can kind of see how that works. So all of this stuff is basically only used for reverse projection now, except for the focal length, which is the part that we're actually using to generate the perspective transform. So I think in terms of what we actually need, we probably can just reverse everything out with just storing the screen dimensions is probably all we need. So I think what we probably do in here is say, all right, for the camera transform, we're probably not going to store the screen center anymore. We'll probably just store the screen dimensions. Right? And this will be like our new sort of compact definition. And we'll go from there as we go. So let's just go screen dimensions. There's the pixel width and pixel height. Oops. We won't store the half dim anymore. And this will be the same in both. And this will go away. And so really these will become essentially the same, and the only real difference here is whether you set the focal length and the camera P. That's about it. So these are basically now the same routine. We could even really merge them if we wanted to by just passing a Boolean in here for whether or not the thing was perspective or not. So for example, if we wanted to, we could just have something that was more like this. And this would just be this routine, exactly as it is. And this would take a superset of the parameters. Right? And that's all we would need to do, right? So then, when we're doing a perspective transform, we just say, oh, please set the camera transform to this focal length and this camera P, and we'll just pass false, because it's not orthographic. And then in this case, we'll pass true, and we'll make up the focal length and the camera P, just like we were doing before. And then we just have one routine. Oops. We'll just have one routine that sets that up, and you can use it in either way. So then if we start to look at this, like I said, the only things that we have trouble with here are unproject, which unfortunately is not going to work anymore, because you can see it needs to do some operations, that it doesn't have the information it needs to. Now, screen center, though, if we take a look at what's going on here, it really only is looking at unproject. It's looking at the screen center. There's not a lot more information that it actually needs here if you look at it. So actually, if we wanted to make unproject work properly, all we really need for screen center in this case is to generate that value. And since we know, since we actually already have that information, excuse me, we already know what that value actually is. We can just compute it here, right? The screen center is just half of the screen dimension, right? Because we know that's what we, when we're correcting for window coordinates after the fact, we know that we want 0, 0 in the center of the screen, so we just need to go halfway to the width, halfway to the height. There's nothing else to it. So from here, if we want to, we can just say transfer and screen dim and produce that value. That solves that problem. And then everyone's happy. I thought we also had a problem with the fit render distance, the monitor half dim in meters. I don't know who's calling this or where they're getting that monitor half dim in meters. So I'm just going to take a look. Fit camera distance to half dim. It looks like nobody's using this yet, so I guess we're off the hook for right now. But as soon as somebody uses it, we're going to have to replace that. They'll run into the problem of not having that value, basically. All right, so that's where we're at. And now when we call it, what we should get is basically exactly the same game, but we'll just be at slightly the wrong place, right? The wrong zoom level. And the reason for that is we were applying a world scale before, and we're not applying a world scale now. Now that makes it pretty simple for us to deal with, obviously. All we have to do is when we're setting up where our camera is supposed to be, we just move the camera closer, right? There's nothing else in particular that we have to do because it was just a uniform scale that was happening. There really isn't much else to it. So all I need to do here is when I do add room code and we're creating how far the camera should be, all we need to do is just say, like, okay, we need the camera to be at a different height, right? And we don't really know yet because we haven't done the rest of the work. We don't really have a concrete idea of exactly how we want the camera to work yet because we're still doing our transition to 3D. But otherwise, we're pretty much we're at the place where we want it to be. Now, the white rectangle there is, I don't remember what that's supposed to be representing, but it looks like that's in the wrong place. So I'm interested to know, we should take a quick look just to see where our debug rectangles are supposed to be and just make sure that those are still working properly. So the white rectangle is this one right here. So the white rectangle is world chunk. I don't really know what that's for or why it was there. I'm going to get rid of that because I don't really know why we needed that at the moment. But I am curious, so it would be nice if we had a little more information here. Like, I don't see our other rectangles, which is not, like, I don't know why we don't have our other rectangles here. Because I feel like we should see our other rectangles, like our screen bounds rectangle. And furthermore, I don't know how we're doing our screen bounds at the moment. So we should take a look at that as well. Like, where's our screen bounds? Get camera rectangle at target. So let's take a look at that. Camera rectangle at target. There it is. So let's see. So monitor half dim in meters is still being used. That's the problem. There we go. I was going to say, I knew somebody was, I think we did that search. I was like, it should have been somebody else. OK. So let's take a look here at what we've got. I don't know why we still have this unproject old situation going on here. It looks like we didn't. I guess it's because we wanted one that didn't have an object transform with it, I suppose. But anyway, so if we take a look here at our projected XY and our at distance from camera, this thing is using an unproject old. It's pushing the monitor half dim in meters down there. And what you'll notice about that is that's not actually, I think this was just kind of us sort of cheating a little bit. And we probably did it first, so we just did it in the minimal way, which is fine. But if you take a look at like unproject, for example, in unproject, what we have the capability to do here is unproject actual screen coordinates. Since we know the dimensions of the screen, we should be able to get a camera rectangle out of that by just unprojecting the two corners of the screen. The minimum corner of the screen and the maximum corner of the screen should unproject to the rectangle that we want, right? So it should be relatively straightforward for us to do that. And the other thing that I would say about this that's a little bit odd is if we look at what's actually happening here for rect center half dim, again, this is kind of a nonsense number because this is not actually placed in the world where the camera is going to be either. And so, you know, we were sort of, this is kind of a misnomer routine. And it was actually, it's clear that we didn't actually care about that. Like we did, the screen bounds that we're passing, right, is just sort of a rectangle that doesn't have a placement in the world. You can see that. You can see that pretty clearly here, right? When we actually call get camera rectangle at target with render group, you can see that we create the boundaries from that. But then when we actually go to use them, we pass a camera P as well. So those sim bounds are actually just the rectangle. And what's interesting about that is we could actually start just passing a rectangle that was in the correct space potentially, but the reason that we don't do that is because the rectangle would then have to be in full coordinates, not local coordinates, so it wouldn't just be floating point value. So yeah, so when we call get camera rectangle at distance, what we're really producing here is just the size of that rectangle. So it's really not a rectangle. In some sense, it should just return a v2, which is the size. That's probably what we should have done to be a little clearer about what you were actually getting. But you know, we didn't do that. So maybe we'll change that. Anyway. So at this point, what I would say is let's use unproject here as the thing that we want to do. Now, the object transform, as you can see, the object transform has an effect on these. The object transform will modify the thing we're using. What's unusual about the object transform is, I don't think, well, no, OK, we do. So you can see us using the z value for the unproject there, modifying, you know, getting combined with the camera z there. And so I think if we want to do unproject here, all we need to do is just not actually bother using any object transform at all, and then we should be fine. So we don't need unproject old anymore at that point. That can go away. And if we do get camera rectangle at distance, with distance from camera being the information we need there, then if we take a look at object transform, which is here, right? We can do get default, you know, the thing that gets the default object transform. There it is. We'll use the default flat transform. So if we have the default flat transform there, all we have to do is then set the z for that, right, to be that distance that we wanted it to be, the distance from camera. Now, the distance from camera in this case is measured in the opposite direction, right? So the distance from camera in this case should actually be, well, no, I guess it's just always going to be, no, because it would be negative, because distance from camera is moving out along the negative z-axis. So the distance from camera in this case would be negative, right? Because z comes at us, and we're saying we're pushing this away from the camera, is the phrasing of this routine. So I think that we just want that to be negative distance from camera, right? And it won't matter in this case because it's going to be 0 anyway, since the one we're calling is this, but you know, just to be consistent. So if we produce that transform and then we do an unproject, then what we can do is we can get both the things we want. So we can get min corner, and that'll just be an unproject with this object transform. And the pixels xy is just going to be 0, 0. And then the max corner, we would just pass the screen dimensions. So then we have untransformed the point at the bottom of the screen, and we've untransformed the point at the top of the screen. And this would give us the real rectangle, right? So that's the actual thing that we actually wanted to know as a rectangle 3, right? Because now we've got a rectangle 3 result that has a min corner and a max corner, and I don't remember how we constructed these. Rect min max, there it is. But now that's producing the actual rectangle in 3D space that represents the rectangle that the camera can see out at a certain distance, which is what we want. And I feel like this is a much nicer way to do this. Like I said, we're just kind of, this is nice going through this and turning it into 3D. It makes me happy anyway. Because it sort of, you can see things start to get more and more uniform, less hacky, right? Because instead of sort of making all these decisions about how we were doing 2D stuff, condensing it down to 3D just makes things much cleaner. Like, okay, so now we're unprojecting. We just have one unproject call. Everything else is phrased in terms of the unproject call. The unproject call is getting more and more simplified. You can actually see even here that the unproject call is now just one thing that happens with the perspective transform slightly differently than the orthographic. We could, if we wanted to, actually do this, right? And then in place of A, it's just this again, right? And so this sorts of gets a little more condensed as well, and it just gets nicer, you know, as we go. So, all right, if I compile that, we've still got a little bit of problem stuff to clean up here, obviously. P is not a member of object transform. Is that true? Where is my object transform? It is offset P. Here we go. We've got a screen dimension here, which I think it's the camera transform that has that in it, right? And then down here, we have that rectangle 3 that we're getting back, like so. And then we just have to take care of update and render world, which is the place this is actually used. So we want a 2-dimensional screen bounds out of this. When we get this back, we're going to get camera rect. Or world camera rect. So if we want that screen bounds, what we need to do there is we need to say, all right, if we just want the screen bounds back from this, we've got the world camera rectangle. That world camera rectangle does have the information that we need. So we just need a rect, you know, min max for this sausage element, and we wanted it to be based at v0, 0, and then we just wanted the dimensions of it to basically be like world camera rex min corner. Remember how this is phrased here. Dot min. So we just wanted its min corner and max corner subtracted. And that's all. So we just wanted the 2D span of this thing. So that's all we're going to do. So in theory now oh dear, what have I done? So in theory now, and only in theory, as you can see from the running, we have that straightened out, but we obviously have a problem in there somewhere. So we'll have to go and figure out what we set askew. Oh, I know why. It was rectangle center dim. This was supposed to be centered around 0, 0. That was the format we wanted. OK, we still probably have problems in there, but this is it. There we go. I guess we don't have problems in there. So in theory, that gives us back that rectangle that we wanted, and it looks like that's giving it back to us properly, because now we're simulating the region that we think we're simulating, which is what we wanted. All right. Now, I don't know why I'm not seeing it, though. That's a little bit weird. I wonder if I set the debug distance. like, I'm just not seeing those rectangles, which I don't understand why I'm not seeing those rectangles, right? The pink rectangle is there, but the other ones aren't, which is even weirder because that means it's working sort of. Okay. So let's take a look. We're drawing the screen bounds, the sim bounds, and the world sim region. So the pink one is the world sim region bounds. So the sim bounds and the screen bounds are both like used to build that. So it seems sort of bizarre that we're not seeing those like we should. I'm going to step in here because I just want to see, like at this point, I'd like to know what those actually are. So if I come in here and just take a look inside world mode at that actual code, I just want to know what the, what the values of those are. Oh, it looks like I did pick the right one. So here we go. And you can see us getting the dimensions of these things here. So here's the screen bounds. Here's the sim bounds. Here's the world sim region bounds. All right, so the screen bounds are nuts. I think we can all agree that they are just completely ludicrous. So we're going to have to take a look at what's going on there. The sim bounds are very reasonable. So I'm not sure why we're not seeing those. And the world sim region bounds. OK, so those just happen to both be in the same place. So we're just drawing the same thing twice in this case. And I guess that makes sense because we decided not to enlarge the sim region anymore, I think, is what ended up happening with that. So I guess that seems reasonable. We'll probably still play with that a little bit more as we go, but that makes sense. So here in our push rect outline call, we know that our screen bounds are janky. So let's go up here and find out what's going on with that. Especially because we're using those here to produce some other stuff. So I'm not sure. I guess it's because we don't actually use the boundaries of that when we get to the end here. So let's go ahead and step into our transform call and see what I messed up there. Here we go with our camera transform. So the distance from camera in this case should be 0, which is what we would expect. So now we're going to do an unproject with that transform. And let's just take a look at what the camera transform is screen dimensions wise. So here's that screen dim. It's exactly what we would expect, right? 1920 by 1080. That is exactly the size of the screen that we would expect to see. There's the focal length, which is what we set it to. I mean, within floating point precision anyway. And there's the camera P. Well, okay, so that's a problem. So the problem here, we don't have distance from camera anymore. So the way that was working is distance from camera actually is going to have to be passed to be what you actually think the camera distance is. So because the camera transform isn't giving that information at the moment, what's going on there? Because that's the problem right there. So how is that working? Inside, here we've set the perspective camera here. So that should have already been set. And the camera offset should have been, I would have thought, the camera offset should have been, let me go ahead and run that. The camera offset should have been set to something like 11, right? So what's going on there? Like that, there you go. I mean, there's a camera offset of 10. We're setting that here, so the camera P should be that thing, right? There's the 10. So now when we come in here, why wasn't I seeing that? Was I just looking at the wrong thing? Oh no, there it is. Okay, so that's all fine. Okay, so here we've got our screen center information, which is exactly what we expect it to be. In this case, we're setting the 0. We're trying to get the 0, 0 corner for our pixels. So we do our unprojection. We subtract the screen center away. And then we should have a balance coordinate. We do. That's exactly what we're expecting. We're taking the camera PZ and the offset PZ. So in this case, we should end up getting that 10 value here. And we're dividing that by the focal length of 0.3, right? And then we're multiplying it by the unproject. So that should give us, where's our unprojected? That should have given us that is not what I would have expected. So I think, you know what I just realized? So this is not the correct transform anymore because this is still doing the unproject the way we used to be doing the transform. But we are using the sort of shrink to negative 1 to 1 and then blow back out to the screen transform now from OpenGL. So this transform is not going to be accurate. We need to redo this unproject. Excuse me. All right. So we actually need to redo this unproject to match the transform that we're actually doing. Now, one of the things that's probably true at this point is because we want to match the unproject here, what we probably want to do is we want to sort of unify these two code paths, right? So we're setting this matrix up here, and this is the matrix that will, things will be getting multiplied by in OpenGL. What we probably want to do is have some way of saying, let's set this matrix, let's think about what this matrix should be in our actual render code directly, so that when we want to do something like an unproject, we are always doing that in a unified way. So I feel like we want to get there. I don't know if we want to get there immediately. Like I think I want to fix this unproject first, and then smush them together more. But I feel like that's where we want to go, right? Because otherwise, they're sort of separated pieces of code that just happen to line up with each other because we worked out the math for them. But it would be nice if we just had, if we just had this matrix, for example. Let's say we just kept this matrix inside the render code. Then when we go to unproject, we just unproject by the matrix, right? And we wouldn't have to think about it as two separate pieces of code that happen to line up. It could be a little more unified. So I feel like we want to get there at some point. But right now, we'll just kind of work this through the way that we need to for this particular function, and we'll kind of just keep an eye on it. So here's day 360. And this is unproject. So here's our project projection matrix. And we've got, you can see the diagonal happening here. So these are the two coefficients that we're using. So anything that comes in here is going to get multiplied by 2 on and off. Sorry, it's going to get multiplied by 2 for the x and 2 times the width over the height for the y. Right? And that's going to shrink it down, and then it's going to get expanded back out by OpenGL using the screen size, right? And you can see that what's missing here, first of all, is we have to think through what part of this cancels out. It may be that this already cancels stuff out, but you can see right here that we already have a problem, which is that the screen dimensions itself, OpenGL is doing that normalization for us. So we do a transform, and our coordinates come out -1 to 1, -1 to 1 in all dimensions. OpenGL then multiplies by the screen dimension. We are not dividing by the screen dimension here, right? Which we would need to do. So when we do this on project, the first thing we would need to do after we do the shift right here, we would need to take the x and the y, and we'd need to basically take that inverse screen dimension and put them back to -1 to 1 coordinates, just like we were doing before, right, in order to reverse this transform. And then we also need to obey the aspect ratio offset of them, right, because we're doing that here. So we have to also do this exact operation in reverse, which is going to be the doubling multiply. And then we can finally, at the end of all of that, undo the other piece of the transform, right? So the unprojected xy.x here is going to be, you can see what this is here. It's going to be a divide by 2 here, right, or a multiply by 0.5. And then for the y coordinate, it's the same thing, except it also has to invert this. So it's the height over the width there. So we've got essentially a height. I'm sorry, it's the width over the height there. So it's the height over the width here. Right, so you can see me just doing the opposite of what we were doing, right? Now, since this is a divide and this is a multiply, I can just roll these in together if I want to, right? Oops. Same here. And I could think of this as the aspect correction term. Right? And furthermore, since I've already got a divide in there, what I can also do here is say let's just go ahead and leave the aspect term the same as it is in the other one. Because you see here we had x over y. So if I just put that in the numerator here, that'll invert it. So that way our aspect term is the same term in both, which again, like I said, I want to kind of get these to be a little more uniform. So that undoes the projection that OpenGL is doing for screen coordinates. And then all we have to do is take it from there. That would produce what we would expect. In terms of our unproject. So from there, what we would need to do is say, OK, we then, once we have it in there, we've got to finish doing our z. So from there, we would take it to just the stuff that was in the OpenGL basis. I mean, it's not the OpenGL, the get render entity basis p stuff. And you can see what's going on there. There's some nonsense with the height off floor and all that stuff, but we were going to get rid of that stuff anyway. So that stuff will kind of come away. But we've got that 1 over distance to peak focal length that's happening there, but that's really all that's happening in the projection, and we've done that part. That part is still happening here, so we should be OK. Now, I don't know if we've got everything there, but at least we're closer now. Let me see if I can step into that code again. I want to take a look at that code now. So here's our world camera rect computation, and that's much better. Right, that's what we would have expected to get. So now I think we're in much better shape. You can see there our camera rectangle looks like it's much nicer, aligned exactly the way that we would have expected it to be. Let me go back to the config. Turn that back to false. And then now we're in good shape. And now we've got those rectangles exactly where I expect them to be now. So now I'm a much happier camper. You can see that one bounding the room and then the other one bounding the camera, and they're perfectly tight. They're right where they should be, and that's what I wanted to see. OK, so like I said, baby steps for our conversion to 3D, baby steps. And I should take maybe a second just to mention while we're doing this. I never said this at the beginning, but I should just kind of mention, sometimes people get really scared when they have to change code, and like this, and The way that you get to a well-working engine and a really good design and all those sorts of things is to always keep your code very fungible and maneuverable like we have done, and to not be afraid to make changes to it, right? To always believe that you can work it out, that if you think it through and look at how things are flowing, you can come up with good changes and break things into baby steps where you can just improve the code and get it towards where you need to go. It's crucial to not have that fear, because it will really hold you back if you're always afraid to go make serious substantive changes, or if you think you have to rewrite everything all at once to do something. Because a lot of times taking the approach of just like, let me delete everything and rewrite the whole thing, while sometimes that is necessary, a lot of times keeping the code fungible and making small changes towards what you need ends up with a much more robust, much better design in the end, because it's hard to conceptualize everything in your head for a giant thing like a game engine. And so what we're kind of doing here for this 3D transform, it's to move the thing from 2D to 3D, it's very important to understand that these are the kinds of changes you want to feel comfortable making. Don't be scared about them. They are very large, but if you break them into small pieces, then it's not so scary, because each individual thing you can measure, understand, test, see if it worked, have an opinion about whether it got better. And unless you literally just can't see any series of steps that will get you from where you are to where you need to go, it's a very sound, very reassuring programming practice you can go through. So even though this is a very significant thing, taking an engine that was supposed to be 2D and making it a 3D engine instead, it's really not that bad as long as you just do those steps. And you could see, like, that camera thing was exactly that. It's like I took a step, why isn't this thing working? Oh, let's go see why. Okay, right, we need to unproject, we need those to match up. How do we make those match up? There we go. Oh, we noticed something that we probably want to improve. The perspective transform should probably exist in a unified place. So now we've got something kind of in our mind of like, this is a way we can improve the code. That is how these things are supposed to work. They're how they get better, and that's how they get better reliably. Because as long as you're always pushing it forward and doing those small changes and seeing that they made an improvement, you're in good shape. All right. So now what I'd like to do is focus a little bit more on trying to get the actual Z stuff working the way that we want it to work, because right now we are not using the Z. So we, I guess that's a little bit misnomer. Obviously we are using it. We are not, the Z is not coming through to OpenGL, right? This is the Z happening here. And what I'd like to do is get that Z moved over to OpenGL so that OpenGL understands and sees our Z coordinates again, which right now it isn't doing. We are passing the Z's down, but we're only passing them down after they've already been projected. So what I'd like to do now is try to get this down into the OpenGL code. OK? OK. Now, this is a relatively difficult change. Not because the math is going to be complicated, because the math actually isn't going to be all that complicated, but rather because right now we don't have a concept in our rendering system of the transform for Z being set at any real time. Okay? So when we call OpenGL set screen space, you can see it happening right here. When we call OpenGL set screen space, we just kind of set it and then forget it, right? It's a set and forget kind of situation. But what we're probably going to have to do is take our cliprect concept, which is the thing where we sort of have stuff that references a particular cliprect. What we're probably going to have to do is take that cliprect concept and augment our cliprect concept to not really be about cliprects anymore, but to be about transforms in general. Because we need some way of telling OpenGL what the camera transform is, and we don't want to tell it what the camera transform is for every sprite, right? That's just like we didn't want to tell it what the cliprect was for every sprite. We could have, right? Every sprite could have its own cliprect. But since most sprites tend to go with a single cliprect, like this big batch of sprites, they're all the same clip rect. We want to be able to specify that once and not have to change it every sprite if the sprite doesn't change clip recs. And the same is going to be true for our camera transform. When we want to set what that Z perspective transform is of the camera, what we'd like to do is just set that one time and not have to set it every single time we do a sprite, right? And you can see why we would have to do that if we'd made no concession to it, because what we are doing here is every sprite, when we get the sprite, we're taking the current camera transform's focal length and we're using it to compute what the Z value is. If we were to get rid of that and just pass down distance to PZ by itself, right? Without the focal length, then OpenGL would have no idea which sprites went with which focal lengths in a case where we change the focal lengths multiple times in a single frame, which we're totally free to do right now, right? Now, the fact that we don't means if we wanted to, I suppose we could just hard code a focal length into OpenGL. But, I mean, even then, we sort of at least need the concept of the orthographic projection versus the non-orthographic projection, because eventually we're going to want to re-enable our debug display. And in order to re-enable our debug display, OpenGL at least needs to know the difference between all the stuff that came down in the perspective and all the stuff that comes down in the orthographic. So at some point, if for no other reason than just because we have a debug overlay or other, we'll probably have other UI potentially in the game that might want this as well, so it's not just for debug. We at least need some way of setting two different camera transforms. And once we can set two camera transforms, we might as well have a way to set an arbitrary number in case we want to do different things with it, right? Because we have to have that concept in there at some level. So that is why we need to do this, is we need to get that camera information down. And like I said, we sort of already have this in the clip rect concept, so we might as well piggyback on top of that because it's already a thing that allows us to have our sprites reference a thing that gets changed infrequently. Right, so that's pretty good, and there's stuff we can do with that. Now, we'll probably be able to improve this further because once we really get to the Z buffer, we won't need to have the concept that sprites reference a clip rect anymore. We'll be able to have it so that sprites just come in batches with the clip rect at the top, which will be much more efficient because then we don't have to do this check on every sprite. And when I say much more efficient, I basically mean, hey, you probably won't even really notice it because it's not that big of a deal to compare two integers together, but you get the idea. It's more efficient conceptually anyway, and we might as well get rid of code that doesn't do anything for us, so yeah. Anyway, so that's what we want to get to, and so that's what I'm aiming for here, and let's take a look at how we're going to do that. So right now you can see that we have this sort of clip rect stuff happening. When we start off, we set our clip rect index to something that's invalid, so the first time through we will always set the clip rect. What that means is that if I wanted to, I could move OpenGL set screen space into here so that when I pull out the clip rect and I do the OpenGL bind frame buffer, I could put OpenGL screen space right here if I wanted to, right? And in some sense, the bind frame buffer call, I mean, I guess I can put it up here. I don't know if it matters where we put it exactly, but let's say I put it there. What I should get here is exactly the same thing, right? There should be no difference between those two, so we're a happy camper when we do OpenGL set screen space right there. So what that means is, sorry, I'm so stuffy today. What that means is if I have OpenGL set screen space here, I could have OpenGL set screen space do something more complicated now. And I'm going to want to do that because now it's going to start to become potentially, at certain times, a perspective projection matrix, right? So there's other people that use OpenGL set screen space, and you can see them here. So for example, this sausage element here, OpenGL display bitmap, right? That's using it, but what we kind of need to do is bifurcate these two things now because they're not going to be the same. So what we need to do here is kind of move this guy in to this code here, right? And furthermore, this isn't really correct at the moment either because we sort of changed this from the way it was working before. Because I think this one previously did the unprojection code. So this draw region is probably wrong now, or this OpenGL rectangle call with the min p max p is going to be wrong now because it's passing a width and height that isn't getting corrected for, right? So I think what we'd want to do here is pass down coordinates that are, -1 to 1, because that's what we're actually passing through, right? I believe. How is this working here? So that's a -1 to 1, it's multiplying by 2, and a shift up. Yeah. So in order to get the correct screen space stuff out of there, if we expect it to go into I'm going to say, oh, we're entering our second hour. How pleasant. I'm going to say, like, in fact, do we have an ability to do this? Yeah. We don't. But you want to know something? We're about to. So yeah, one thing that I tend to like to do this is kind of an amusing code path. I'll show you how it works. So if we are in Handmade internal, if we're in Handmade internal, we can just insert on this. If we try to build a release mode build with it, basically, that we would ship to customers, it's just an error, right? Because you can't put that in the code anywhere. So this is basically a little thing that says, hey, you can't ship any code that has something not implemented that's supposed to be implemented. So I can put that here, and I can say to do this needs to be worked out specifically for doing the full screen draw. And we'll do that in a second because, well, we'll do that when we get back to the software renderer, I guess. So I'm curious now as well if I kind of want to think about this transform a little bit more. Let's go ahead and grab that out here. OK. So if we're in here and we have OpenGL set screen space, now one of the things that's true is we don't use the model view matrix. You know what I'm saying? We only have the projection matrix there at the moment. So for now, I'm just going to load an identity matrix into the model view up front, right? Because we're never using that matrix, and I don't need it for anything. Now, I think we're probably going to switch to shaders at some point. And what you'll see is that when we switch to shaders, at that point, there's no such thing as projection and model view matrices anymore anyway. These are just things from the fixed function pipeline that OpenGL did for various historical reasons. In our actual shaders, we will just have one matrix anyway. So I'm just using the projection matrix because we only really want one matrix for all intents and purposes for doing our coordinate computations, and everything should be in this matrix. So I'm never going to use the model view matrix because when we transition over, which I think we probably will, you don't have two matrices anyway. Because if you think about it, there's really not a lot of reason to have two matrices. The only reason you ever do two transforms is if you have a secondary space you need to do computation in. And so we can look at that. We'll look at that stuff a little bit later. It's not really worth putting it into your brain space right now. But basically, yeah, that's why you're not seeing me do anything with the model views, because generally we want to stick with one matrix for everything for coordinate computation. And if we're going to do a second matrix or something else, it would not be so that we could have two stages of transforming. It would be because we need a secondary space for computation for other reasons or something like that. All right, so anyway, if we load at the projection matrix here and we take a look at what we're doing, here's our aspect ratio correction, like I was saying before. You know, this 2 this is, I don't even know why we're still bothering with the safe ratio here. I mean, really what this is just to multiply by 2. You know, this is just that. And so really the only safe ratio part of it is just the width over the height is the only thing that that was doing. And really we don't even really need that, because I think we should probably just not run if the width and height aren't both greater than 0. We should just turn off the renderer and not run. That's probably the safer thing to do, so that we don't have to worry about degenerate things happening at that case. But for now, those are our 2 actual pieces of transform information that are happening there. And again, the reason that we're doing that is because we want to put things into the correct space for OpenGL. Now, the only thing that makes me a little bit confused right now is why the 2 is there, because what are we actually passing down in terms of coordinates here, right? Like, you know, here we go. So if the center of our screen is at 0, 0, right, and, you know, we're talking about passing down coordinates here, if we were going to pass down coordinates that are -1 to 1, you know, -1 to 1 or whatever, if we're talking about this as our world transform, then I'm not really sure why we were multiplying by 2 there, because in theory we want to divide by 2, right? 0.5 to put ourselves into the right coordinate space, right? Because we want -1 to 1, or really we wouldn't have to multiply by anything, right? If we were already talking about a coordinate space that looked like that. And so I'm not sure why we decided to do that. And I'm going to look briefly at docs.gl for GL perspective, or glue perspective. Oh, well. Just to make sure I'm not crazy about that. That is not a very good... nope, that's not what I want. That is what I want. No. I just want somebody to have that matrix drawn out for me. That's what I wanted. Although, looks like they're missing. Even that's not quite right. Come on, folks. I just want it laid out as a matrix, please. How hard is that? That can't be that hard, can it? I guess it is that hard. Well, let's just pretend I found it or something and ignore it. Anyway, so when I'm looking at this, just the only reason that I was thinking of that is, like, basically these are just dependent on what the coordinates are that are coming in, right? And because what we know is that what we want to come out of here is the -1 to 1 space, right? But in terms of what comes in here, we have to have an opinion about what's actually coming in order to in order to know what those values should be, right? And so we know, like, one thing we do know for sure is that GL viewport is going to do the viewport transform at the end of it, so we know exactly what the coordinates need to be there, right? We know that this is what's happening to our coordinates going in. So we definitely know that they are -1 to 1 when they come out, if that makes sense. But what we don't know is what we wanted them to be when they come in. And so the multiply by 2, again, is kind of arbitrary in this case, right? This could just be an identity transform that just corrected for the aspect ratio. And it just means things get a 2x scale on them. The fact that we are the fact that we are if we were not doing the multiply by 2 here, it would get a 2x scale on them, right? So in theory, right, like I could just get rid of this, and it would just change the size, if that makes sense. Oops. It would not change the behavior at all in terms of anything else. It just means that we're not getting that scaling, right? So if I come in here and I turn it back to 2, then we get that scaling, right? So that's really all that's happening there. And yeah. I'm just not sure we care about that, right? I'm just not sure we care about that at all. It seems to me like that's just superfluous, and I can't remember. I feel like the only reason we had that 2 in there was because we were previously passing coordinates that were 0 to width and 0 to height, right? That's what we were passing down. Then we changed to just passing 0 to 1 on both. And if we're passing 0 to 1, then you can see why the transform would need to make it 0 to 2, because it's going to shift it back by -1 in order to center it. But now we're not doing that anymore. Right? Now we're just passing straight coordinates, and we're not trying to correct for that. So the only thing that we actually need to correct for is that safe ratio. You know what I'm saying? And so I feel like we don't really need that anymore. Like, I don't think we need that multiply by 2. We would, again, just adjust the height of the camera, and I don't think there's any other reason for that too. I could be wrong about that, and we're going to have to work out the projection math in a second here anyway, so I suppose, you know, hold that thought, but that's just what it feels like to me. It feels like that was a superfluous, that was left over from something we were trying to do before that we'd no longer have to actually do. So let's just keep that in mind. All right. So let's talk about this again. I already explained the projection matrix on a previous episode, so you're going to want to get familiar with that if you haven't already. But we never really talked about the z coordinate of the projection matrix, and we need to start talking about that now. So let's go ahead and talk about that. OK. So if you take a look at what's happening here, you can see we're trying to divide by a z value, and we are trying to multiply by the focal length, right? So if I were to phrase this more concisely than it is phrased at the moment, it would look like this, correct? So we're trying to take this value that's coming in, and we're trying to multiply it by this coefficient in order to do our projection. But what you'll notice about this is the divide involves a value that's coming in from the point itself, because you can see this distance to PZ actually takes into account more than just that value, right? So the distance to PZ here that we compute, we do this distance above target minus floor z. The floor z comes from the object transform, which is per sprite, right? Now, why am I harping on that as being so important? Well, the reason I'm harping on that as being so important is if you think about what's happening in our matrix here, right? We are trying to produce a result, right? A resultant vector. And what's in our matrix here multiplies by these things. All we can do is multiply. If we want to include this in a divisor, we have no way of doing that in a matrix, right? There is no way to take something from here and put it in a numerator, a denominator here, right? All I have is coefficients. All I have is the ability to do this in every slot, right? That's all I can produce. So I can have an arbitrary fraction here. You know, I can have 1 over the focal length or whatever I want here, because the focal length is a constant that's part of the transform. So it could go in a numerator because I just stick it already pre-divided into my matrix when I create my matrix. But the matrix is constant for a batch of sprites, and this is the thing that varies per sprite. And I need to get something that varies per sprite into a denominator, which I can't do. Right? So that's where that synthetic divide comes in. Right? That is where we sort of augment this transform. And remember, that's why I was saying, oh, that's where the homogeneous coordinates come in. What's defined to happen is after the transform is done, there will be a value in the w coordinate, right? Whatever the w prime coordinate is that comes out here, right? I'm going to have an x prime, a y prime, a z prime, and a w prime. What I am going to do is, after I do this, not part of the matrix math, I'm just going to divide everything by the w prime. So basically what I'm saying is, whatever my w comes out to be, I will always end up normalizing by it. So the w always comes out to 1. That's just the rule. And all the rest of my coordinates get divided by it, however it's going to go. Right? And as we learned before, a mathy person helped us before I asked why we even use the word homogeneous. You'll see that talked about for this. And that is actually because of that w. So what the homogeneous actually means is homogeneous refers to spaces or number systems where you can represent the same number multiple ways in terms of scaling, right? And what you can see is this is a 4-dimensional vector. And what we're saying is we don't care what the 4-dimensional vector is that comes out. We're going to divide so that the w coordinate's always 1, which means that there's a whole family of vectors that all mean the same thing. They have different scalings, right? So I could multiply everything in here by some scale factor, whatever I want. And I'm always, no matter what a is, I'm always talking about the same point. Because the divide by the w prime at the end, if there's a scale in there, right? And I guess I wrote that poorly. It's if I have sort of a, and then that, right? Whatever this a is, I'm going to produce the same points always, right? Because I can just arbitrarily scale this 4-dimensional vector by 5, and since everything gets multiplied by 5, when we actually go through and do the divide out by the w prime, that 5 gets canceled, right? It just goes away, because everything was scaled by it. So that's where the homogeneous comes from, is the fact that you can scale these vectors however you want, right? So anyway, that is how I am able to get my z into the divide. You can see the z has to come into the w component somehow, because the only thing that's going to end up doing a divide is the w, so it's got to go there, right? So let's just start thinking about what that actually means. I'm going to go ahead and erase. Oops. There we go. Okay. So I'm going to go ahead and start talking about that. So let's say all I wanted to do was divide by the incoming z. That's all I wanted to do. Well, what would we want our x-coordinate to be? Well, we just want to divide the x-coordinate by z, so obviously we would just not change it, right? We would just have it be x, right? 1 times x, 0 times y, 0 times z, 0 times 1, so it's x. What would I do for my y? Same thing. 0 times x, 1 times y, 0 times z, 0 times 1, right? xy. What would I do for my z? Don't even care. We might as well leave it the same, but we don't care, because we're not talking about that yet, right? And then finally, what do I want for my w? Well, I want to divide everything by z. So actually, my w coordinate, which used to look like that to produce this, right, because we just wanted a 1 there, so there would be no divide, now has to look like this, right? 0 times 0, 0 times x, 0 times y, 1 times z, 0 times w. Now what I get when I do my divide, right, ignore that, is I get x over z, right, because the w coordinate is z, y over z, z over z, and 1. And there's my divide. So I can produce any single divide value that I want now, because this extra row, the homogeneous part of this matrix, the additional coordinates, gives me the ability to prepare a divisor using any combination of the input that I want. So now, instead of having to be handicapped by the fact that I cannot do it, right? I cannot control divides by things that come in the input. Now I do have the ability to do so. It's just how I produce my w coordinate. Do you see how that works? So basically, we can think of this matrix as an arbitrary transform that allows us to produce an x, a y, and a z, and then a divisor, so that we do have one opportunity to do a global divide across each of the coordinates, computed however we want it, which happens to be just enough to produce a perspective transform, right? So now that we have that knowledge, right, and remember, things are reversed here, because these are stored column major, not row major, and we talked about that before, so remember what that is. So this matrix is actually flipped from math notation, unfortunately. So what we'd want to do here is, if we were going to do it to match our matrix, it would look like that, right? That's where we'd put that coordinate. And if we put that coordinate there, right, now our projection matrix, whenever it does its projection, will be taking the z-coordinate and it will be forcing everything to divide by it. Now, what we know is that we don't actually want to divide by just the z-coordinate, right? So if we were to say inside our, our p coordinates here, if we were to take our raw xy, and we wanted to take the distance to pz as the z-coordinate, we could bundle that up here like so, right? We'd say we have projected xy, raw xy, raw xy, and then here we've just got our distance to pz. So if we were to take that, what we would see is our camera focal length is now no longer in there. We're just passing the thing that varies per sprite. And we could get rid of this piece of information entirely. Now, our scale, unfortunately, we still don't know. We still have to produce that by this equation, right? So we still have to produce that, unfortunately. But our p-value we could pass through as it was, right? So what's interesting about that is in terms of scale, we're going to have to unwind how that works, because we want all of our stuff to be passed down correctly. So we'll have to unwind that. This is going to be an unamusing two-step process. But so yeah, I guess our scale values are going to have to just come out to be 1 now, and basically the scale, yeah, well, you'll see in a second. So I'm going to stuff that for now, and we're going to get rid of this. And here we're going to pass them down. So we're just going to pass down the raw xy, and we're the distance to pz. And the focal length, I guess what we could do is say we'll put the focal, we'll for now, just to do baby steps again, we'll actually bake the focal length in there, since we're not passing it down yet, right? So now what we know is to reproduce this, we just want to be able to do the divide by this value, right? And so in order to do the divide by this value, like you can see here, it's multiplying the raw xy. we're just going to want to flip this, right? Because we're going to be doing a divide by it, not a multiply by it, like we were doing there. So it's going to have to be flipped around. And then when we do this here, when the z-coordinate comes in, we will now actually be able to shove that into the w coordinate, which will do that divide for us, right? And so we're not, now we got to talk about the scale, but just so you can see what happens when we run it, here you go, right? Okay. So not particularly reassuring here, as you can see. But, you know, all of the rectangles still work correctly. And if you look at why the rectangles work correctly, it's because they don't need that scale value, right? I don't think the rectangles, well, actually, is that true? The rectangle should have needed the scale value as well. And setting the scale value to 1 is probably... I'm going to have to go step through that, to be honest, because I don't remember exactly how we did the scaling. But yeah, I don't know why that worked. I would have expected it not to work yet, because we haven't really addressed some of the finer points of that there. Casey is very confused. So, hold on. I'm sorry to interrupt the explanation there of what we were trying to do, but you know, when I get confused, I have to go investigate. So I can't very well continue an explanation when I'm confused. So when we do our rectangles, I would have thought that those would have had to have the scale correct as well, because the rectangles get scaled just like everything else gets scaled. So when we do a push rect, it does the scaling just like everything else, right? Here is it, you know, here is it getting the basis. Scale comes back and multiplies it by the dimension, and off it goes, right? So, you know, that rectangle dimension is the scale dim that comes through. That should be no different from the sprite case, which is doing exactly that, right? Here's push bitmap. It gets back a dimension. It's multiplying by the scale just like before. Okay. Well, no, I guess no. I really don't see it. So in one case, we have the x-axis and the y-axis getting multiplied by the size. In the other case, we just store the dim directly. But I really just don't see why those two things would produce substantially different results for us. So you can see here we've got the rectangle call. It's calling OpenGL rectangle. It's passing the dimension that it gets in from the code, and that's it, right? And in this case, we're doing the exact same thing as far as I know, right? You can see it here, where these are already multiplied by that dimension, and you know they're getting expanded out to it. But I just don't understand. I don't understand why the rectangle case is working, because the rectangle case I would have thought wouldn't have worked any differently from this one, from this case, right? That just doesn't make any sense to me, because in theory they should have been equivalent. They're both using the scale value that comes back. Either both of them should have worked or neither of them should have worked. Not one worked and the other didn't. So there's a subtlety here that I'm failing to appreciate in terms of what's going on with the bitmaps. And I really don't know what that is. So I suppose one thing is if they're getting clipped, Do rectangles not get clipped? In some way that bitmaps do, you know? Like, are we throwing them out or something? In a way, because of some piece of information, I don't know. That's really bizarre. So I guess there's one way we can figure that out relatively quickly, right? Whether there's any sort of funny business going on there. So let me just check. What I might do is go pull out all the sort stuff first, and then that'll probably take me the rest of the stream. And then, so that's all gone. And then we can just focus on debugging that, just the transform part tomorrow, next stream. But yeah, that's really weird. So I want to check to make sure we're actually getting into here and getting reasonable values. I mean, those look sane, right? Those don't look like ridiculous values. So I don't understand why we wouldn't have something reasonable here. Let me go ahead and see min x, min y, min x, max y, max x, min y. Oh! That may be the difference. Let's take a look. Let's take a look, folks. We may have just lucked out that I happen to see that right now, so it doesn't take very long to find if this is in fact the case. Yes, yes. Thank you so much for all of that. Yeah, okay. Well, there you go. So the difference is in OpenGL rectangle, we were actually passing the z-coordinate, and in bitmap, we weren't. So the reason was not because there was anything different about the two cases in the head end. It's because in the back end, we never passed the actual z. So if we just switch to passing the z, we should be fine, actually. OK, there we go. So there we go. And now one of the nice things about this, right, is that now we get rid of that scale value as well, because now all of that's happening in the backend transform. So inside render group, if we take a look at that render entity basis p maneuvering that's going on, we now can get rid of the scale value entirely and remove it everywhere that anyone was doing anything with it, right? Because it's going to happen as a natural result of what was going on before. So in terms of like this stuff here, where we get the size and that sort of stuff that's happening here, we don't need to take into account the basis anymore. We only need just the raw size for stuff wherever we were operating on it. So again, that basis.scale just goes away. Basis.scale goes away here. And so that's, again, another simplification that we can do, right? And similarly, we should be able to get rid of the valid as well. And so what you can see here is now when we get our entity basis p result stuff done, really it's just going to be a v3, right? We should be able to now just go, hey, let's get rid of that entirely. And it's just a v3. That's all it is, right? Which is pretty great. And simplifies a lot of stuff for us. Oops. I keep meaning to one of these days I gotta update my 4-coder. I always keep it updated on my dev machine. I haven't updated it on the stream machine, and I've made some changes to my config, and I also, updated to the latest version and stuff. And so now occasionally I have a hotkey that's different or whatever. So. And it is very specifically that one. All right, almost there. And we should be good now. And so now we've gotten rid of just a bunch of stuff here, right? This is getting much better. And we still need to pull out all of that sorting code that we don't need anymore. But let's just keep going down this path a little bit here. So now we can sort of see, like, all right, in the orthographic case, we do nothing. Result is just equal to the incoming point shifted by the camera transform. Like, that's it, right? In the other case, now we've got a little bit of business that we do here, but it's getting it's getting increasingly more and more and more concise, right? So we're going to probably get rid of ortho y from z entirely, is my suspicion. So yeah, we're going to have to take a look at some of these and just figure out exactly what we want to do here. But so this stuff should be getting cleaner as we go. All right, so we no longer have to do any clipping to the near clip plane because the OpenGL is doing that for us, right? So we actually can just do this directly. And this right here is our sort of our orthographic height transform, which we need to sort of figure out exactly what we want to do with, but we're probably going to have to address that a little bit later on. And so, yeah, we're getting pretty close here. We don't care about this anymore. And so really what you can see is we're getting very close to being able to just pass the distance pz. All we really need now is a way of setting this focal length for our camera transform, putting that up into the actual code, into the actual camera code. And so maybe that's the thing that we'll do now, right? We also have that 2x scale that we removed. And again, I'm not 100% certain about that. I feel like we got to take one more really careful look at that to make sure what that value should actually be in there. But assuming that we want to keep this the same, we're going to have to sort of zoom in. Not sure how far. Not that far. All right. Enough about that. OK, so again, getting closer. This needs to be calibrated, and we need to recalibrate the camera stuff anyway. But we'll leave it like that for now. So what we need to do, and also bear in mind our unproject. Should probably just write this. Our unproject needs to be updated to be in line with that piece of code as well. But anyway, so now when we get down here, what we want to do is take a look at how to move that focal length out. And what we had before, right, is we've got this concept of these clip recs. and the clip recs are sort of actually one of the few things that crosses that boundary. Like that's actually a render structure that's understood on both sides of the API boundary, right? This render entry clip rect is something that we prepare and that is understood by both renderers, and you can see it here. It's got a render target index and it's got the rectangle, and it's really not a clip rect anymore, but that's sort of what we're calling it. That's fortunately just what we're stuck with in terms of the name. We can rename it later if we want to do a global rename. So all I really want to do now is add in here what we need in terms of camera control. So if I was just to say, let's put the focal length in here, right? Then what you can see is it's lined up correctly so that inside the OpenGL code, when we actually need to get that focal length, what we can do is we can stick that focal length in here. When you take a look at what's happening inside render group, you can see that right now we would be passing the z, but we need to divide it by the focal length first. So what we could do in here is say, well, this is just going to be 1 over the focal length, and we'll get that focal length from the clip rect, right? Because we have that piece of information with us. And that would reproduce the same transform that we're doing, because it would provide that 1 over when we multiply the z. Right, because distance to pz would now be the thing that's stuffed into the z coordinate, and then when it gets multiplied by this coordinate to put it into the w, which is what's going to do the divide, we'll end up with distance to pz divided by the focal length, which is the same term that we had originally, which is what we're trying to reproduce. Right, that's what we want to divide by. Okay. So given that that is what we want to divide by, what we need to do now is figure out how to set this focal length. And so what happens is when we do our clip rect, and we call push clip rect, what we want to do when we call push clip rect is we want to, every time we do a push clip rect, we want to pass that focal length in addition, right? So here's our focal length getting set here, like so. And then just whenever somebody pushes one of these to push the clip rect, what we can do for now is just take a look at the camera transform and get the focal length out of it directly, right? Because we have it, so we can just do that if that's what we want to do, right? We don't set the camera transform here at all, do we? All right. And so when we call push clip rect here, and we're calling this for, OK, so this is pushing the clip rects for the various floors for the alpha clip rect. So in this case, we just need, again, the camera transform. So whatever the render group is, in this case, past the focal length, right? So what we need to do now is we just need to respect the fact that, hey, if we want to do that, the problem is when we do the first push clip rect on the begin render group here, we don't actually have the focal length that we actually need for that initial clip rect, right? We don't know what it actually is. And so in some sense now when we're doing sort of this set camera transform and begin render group are kind of now like they need to be sort of smushed together, right? Because when we do begin render group in this case, we have to have that information already available, if that makes sense. What's really interesting here is you can also see that we keep the screen area out here. So I guess I really didn't even need this because that was in the render group. So that was really kind of redundant. I didn't really notice that when we first did it. So yeah, we should probably take care of that as well. And this sort of set camera transform is kind of a thing that, Yeah, we can condense this down quite a bit. So if you take a look at what happens here, if we do render group, what I'm going to do is just push a new clip rect on and pass that focal length, like so. Okay. And I think there's some interesting things that we'd be able to do here. What does it want? From R32 to U32 for the pixel width. So I guess we can just use render group screen area. Or whoops. These are all U32s here. There we go. All right. So we can clean this up fairly considerably here. So you can see that now we're getting the exact same results we were getting before, which is nice. But now we're actually doing that divide with the focal length. We're actually doing that in OpenGL, right? So now the focal length is actually coming through here and getting set with the camera transform. Now, it looks like we've got a whole bunch of stuff that can collapse out here, so we might as well just do that and make this a lot cleaner. Since we know the screen area here, that means the camera transform itself can be limited to not actually have that information, and I think we're going to see a lot of stuff start to come together here. So if we want to, we can just say, OK, the camera transform no longer needs that screen dim anymore, right? That's just not on the table anymore, because we can just get that out of the group, right? And that produces what we need to produce. It looks like that's actually a rectangle. I don't know why that's a rectangle instead of just a dimension. Because we are never really doing anything else with it. Let's see here, screen area. It's always produced as a 0, 0 to width height. That's the only thing we ever do with it. So I feel like we can just treat that as a regular screen area and be done with it, right? I feel like we could just do this, and that's it. So that just becomes the screen dim. And everywhere we were getting that out of the camera transform before, we just get it out of the render group now, right? Like so. And same thing here. And same thing here. So what's interesting about this, if we take a look at it, the screen dim pixel width, pixel height stuff is only, it's just not being used there. So it's really only used for this call now to redo the clip rect. But I think we're all good still. Yes, we are. So again, just simplifying that further. And then the next question is, well, can we take that to an even, can we continue to push that down and just say, well, all right. So the camera P, the focal length, the orthographic, can those just be on the clip rect now, since the clip rect is just going to basically be our camera transform, right? And the answer there is, well, we need some information about those, so we can't keep doing this thing where we just, when we do current clip rect index, where we're sort of, we can't keep doing the thing we were doing where we don't remember the clip rect itself. So in here, we're going to have to store a clip rect where we, when we push it on, here's our push clip rect call, we're going to need to store that current clip rect as an actual accessible value. So every time we do the current clip rect index bit, right? So current clip rect index, when we do the push rect on these two guys, right? which looks like the only time that's actually set, we need to actually record the value. When we do push clip rect, I'm not sure. So what we're probably going to have to do is take a look at who's actually using these values and have a thing where that, because I guess people switch between them, right? We're kind of going to need a notion of which one you're talking about at any given time, right? And the current clip rect index part itself, I think we're in order for the way we want to use these, we're just going to have to clean this up a little bit, right? Because we need to get that information out of the clip rect, and right now we can't really, and people can set that arbitrarily and may want to ask questions about it, right? So we can do it this way, and this will work okay for a second, but we're going to have to do it a little bit more intelligently here in a second, because we don't have the information that we need at our disposal, right? All right. So let's take a look here. How do I want to go about making this change? Because this change is actually a little bit sassy, in my opinion. So I guess one way to make this change is let's just overdo it, if that makes sense. So we've got the camera P here, and we're setting it in the camera transform. And basically what I want to do is I want to get rid of these two. I pretty much want to get rid of the camera transform, right? And I want to just have clip rect, and then we'll probably rename clip rect like to be camera transform, right? So that we just have one central structure that encompasses everything we need for that projection. And then that way when we do forward or backward projection, we're always talking about one thing, and it's consolidated in a nice place. I only have 10 minutes left, though, so I don't want to try and make the whole change at once. In fact, maybe I should just go to the Q&A now, and we'll do that tomorrow. That'll be tomorrow's job. And we'll just leave it like it is at the moment. That may be a good idea. Yeah, that may be a good idea. I could go, although I have 10 minutes, I might as well, you know what I might do is let me go pull out some of the sort key stuff. Let's just see what we can do in that regard, right? So I'm just curious here, what could I do along those lines? Like, what could I do if I wanted to get rid of sort of the push buffer sort stuff? So what I want to do here is kind of get rid of some of this vestigial remains where we're doing the sort entries and those sorts of things. So what if I just sort of got rid of those entirely and tried to move us back to where we were before? So we just have a render group entry header, and we actually are just pushing those in, right, in place. And I want those to go up like they used to. Well, oh no, those still do go up, so that's fine. It's because these were the ones that were pushed on the end. So what I'm going to do is I'm just going to say, all right, suppose I get rid of the sort sprite bound stuff entirely so it just doesn't get pushed on anymore at all, right? So I'm just going to get rid of that. We don't push that on anymore. Now, what should probably happen is I won't see anything on the screen at that point because, well, oh, that's interesting. So somebody still thought they were pushing something on. I guess, I'm not sure why. Oh, because when I do that push buffer, I do push a sort entry count. So what I got to do is I got to get rid of that sort entry count, right? Because we don't want that anymore. We don't want the sort sprite bound stuff anymore, right? So this stuff is no good. So we're just talking about this. This is the only thing we need to do. Yeah, and that's it. So we get rid of the push buffer data at. We put the header there, the sort bounds, sort entry count, that stuff goes away, right? So that's how we're pushing stuff at the moment. There we go. But now we should see nothing, I would think. And the reason that we should see nothing is because we're not actually pushing on any of those sort entries. Now, push render element still looks like people are looking for these sprite bounds. So let me go ahead and really just get rid of them so we can clip out all the code that was referencing them at all. So this means in our object transform, you know, or rather, let's see, in our stuff that talks about sprite bounds, we would just get rid of all of this stuff, right? It's all gone. None of this. It's all just, you know, it was fun for a while. You know, we did what we had to do, but it's gone now. And goodbye, right? All right. So we get rid of all these guys, and we get rid of, oops. Get rid of sort barrier. Although actually, I suppose, let me just leave the call to sort barrier here for now. Just because we may want to still use that, even though we're not sorting, we may still want to clump things together occasionally. So, you know, I won't remove that too early. All right, so here's our push render element call. We get rid of the sort key on there. The aggregated sorting is gone. And let's see here. So get bound for, that looks like it's all not necessary now. And the screen area is not necessary either. 5-minute warning. All right. Let's see here. Not enough actual parameters for macro push render element. Push render element. That is because it's still taking these things, which we don't want it to. And let's take a look at some of these other ones. Those go away. We no longer need to call them. Yeah, where is that at? Sprite bound, screen area, not necessary. Oops. We'll get rid of the aggregate sort key. We will have to do some work with those in the future, so it's not like we get that entirely for free, but. And then so the draw bounds, we don't have that anymore, right? Because we won't be having any of those sort keys anymore. So those are all gone. And the show sort groups is gone as well. And then we just have to get rid of the all the sorting code, because the sorting code can no longer operate. So build sprite graph is gone. Unsorted output is gone. Recursive front to back is gone. Sort entries also gone. Linearized cliprex still definitely exists. So, you know, prep for render is still going to have to do that operation, but that's about it. And then I think we're back to normal, except, again, now we should not see anything, right? Oh, and I forgot to eliminate that guy. It's an unnecessary assertion. Oops. Push render element. So here, when we get that push sort entry, where was that sort entry being? Here it is. So push buffer result is just going to be the render group entry header, is the only thing that will come back now. And we could probably get rid of this struct as well if we wanted to. And when we do this push here, and we get the invalid code path, I guess, you know, I'm not, we could probably just not draw the sprite, so I'm not sure why that's a hard fail there. It seems a little odd, but whatever. We'll cross that bridge when we come to it. So yeah, so here we go. Let's see, our sorted index count. I'm not sure why this, I guess the sorted index count is not getting initialized. because we don't really even want that anymore. So let's go ahead and I can clip that out, sorted index count, that in the platform code probably. So when we do the game render prep, this code goes away, right? It's just the clip recs now. And so this loop is now what has to really be updated so that we correctly pull out sort of the header values instead of what we are pulling out now, which is, not that. So really this code is going to be a I guess just a max size, really, because these things that we're pushing on are variably sized, and we're advancing by a variable size each time. And so since we're advancing by a variable size each time, really I think what we want to do is say, like, okay, we've got the header offset that's going to be starting with 0. The header offset has to be less than the like render buffer size kind of a thing. And then we don't actually do any of that. Instead, what we do is, in any one of our cases, when we see something, we need to advance by the correct amount, right? However big the thing is that we're actually looking at. So we have the header, and we want to advance by the header size, but then we also need to advance by whatever the size is of the data, right? I'm not going to do that this time around, right? I think I'm just going to do if 0 here for now. And that's what we'll do tomorrow. And I think that's about it. So let's see, in our software renderer as well, we've got one of these loops. Here it is. So we're going to have to do the same thing here as well, right? And there's that header offset. Yeah. And so now we just have a non-loop, right? Oops, it's not going to do anything. And we can leave that like that for tomorrow. And so all we have to do is just restore that loop, and then the sorting code is gone, which is nice because that way we don't have any of that nastiness. So let's go ahead and go to the Q&A. Wow, no questions. Well, we can go home early, I guess. All right, well, if there's no questions, then I will just end early, and that will be that. Quartertron, can you please go double check your matrix math in your last drawing in Milton? Sure. Okay, what is the matrix math you want to be able to check? Okay, so you just want me to redo this multiply, I guess. So x times, I mean, I can do it all the way out. 1 second, let me get rid of this here. All right. So we're multiplying vector times matrix here. So we have 1x plus 0y plus 0z plus 0 times 1. We have 0x plus 1y plus 0z plus 0 times 0. Oops, sorry, 0 times 1 here. We have 0x plus 0y plus 1z plus 0 times 1 here. And we've got 0x plus 0y plus 1z plus 0 times 1 here. So, simplifying these out, you just get x, because all of these go away, y, z, and z. So x, y, z, z, which is what I wrote, right? So that more scroll right-ish. Okay. This. So this is x over w, y over w, z over w, and w. Right? Okay. Okay, Quartertron. Well, it never hurts to double check, right? I mean, math is, and I'm rusty at math. I don't do as much math as I used to, and I was never particularly good at it. So, double checking math is always rarely is it a bad idea to double check your math, I guess is what I would say. Let's see. Okay. Are you planning on making a video featuring everything you made? You mean like a summary video? I mean, eventually, like when we're all done, we'd probably do something like that, right? But, that's gonna be a while. We got to finish the 3D stuff, and then we have to implement a bunch of game code so that you have something to play, with an objective and loot and things like that go into these game things that people game. So, we'll maybe do a summary video at the end. Pep eval. What do you have in mind when it comes to shaders? Do you plan to use them to sort? No. I don't really have any plan for shaders at all, other just than the fact that I think we would probably have to switch to them for lighting. Like, we're going to want a little bit of lighting stuff in there, and a couple things like that. And we don't need anything complicated, but shaders are really the only reasonable way, once you are drawing on the GPU, to really get a lot of that stuff. So the Z buffer will take care of our sorting for us mostly. We'll have to do a little bit of stuff in there that's, in a shader we might have to offset the depth value So because we want to do stuff like have artificial like overlap changes based on, you know, what's supposed to be on top of what, and, you know, who knows what else. So there might be a little bit of stuff like that. But, you know, the shaders by and large will not do much. You know, it's just even, I guess what I'm trying to say is even just basic, simple things like basic lighting calculations you might want to do. Once everything's rendered on the GPU, assuming you want to do those light calculations per pixel, you have no choice but to do them in the GPU anyway. So even if you don't care about the speed, if you just want per pixel lighting, you have to write a shader. That's the only way you can put your own, even very simplistic code in for doing some light calculations. And the only way you can do any lighting calculations in the fixed function pipeline is using this ridiculous light system that's really bad and was baked into the original OpenGL thing for back when hardware could hardly do anything compared to what it can do now. So, you know, do we really need shaders for anything? Not really, but, you know, the small expense of querying it and uploading a shader is usually worth it just to get the simplicity of being able to write our own little lighting equation in there, you know, when we need that. That's all. Let's see, JEKASG, how long till ship? I don't have any particular plan for ship. Like I said, this game is a teaching project, so it doesn't have to be released at any particular time. So it'll ship when we have implemented all the things that I think are interesting and useful for us to implement in the context of the game, and, you know, we've done a nominal job on having enough game there as well, so that, you know, it's a nice playable experience that people would enjoy. But that's it, you know. So I don't have a ship date in mind. Rome, I'm running out of excuses to clean the garage, so someone asked something long. Okay. All right. So I'm basically here to allow you to procrastinate from cleaning your garage. I see how it is. Vargasmarin, could you expand on the topic of refactoring? Sometimes all the code I use Git to move on, but keep my old code, so I think I'm scared of changing things. Yeah, like I sort of alluded to there when I had that brief kind of interlude and said that you can't be afraid to change things. I guess what I would say is that it's difficult. It's difficult to get to the point in programming where you are comfortable programming what I would consider a professional level, which is a bit of a misnomer because there's plenty of professional programmers who can't do this. So professional just means you get paid for it, I guess. But getting to the point where I think, you know, you're a good programmer. You typically go through a couple sort of phases, and what's interesting about it is, like, you kind of return back to where you came from, but just much better than before. When you start out programming, you're not afraid, usually, because you just don't know anything, right? Like, you're just typing code in, and you're just happy to see it work, and you haven't been inculcated with any, you know, nonsense about what's clean code or stuff like this. And you also don't have any experiences where you've gotten burned by something. So, you know, you're in this sort of fairly innocent place as a programmer where you just can do whatever you want, and you're not afraid because you don't have anything to be afraid of. The only thing you might be afraid of is that you can't figure out how to make the thing you're trying to make, right? You're maybe afraid of your incompetence, if you will, right? But you're not afraid because you think something is wrong or something's going to happen. You're just afraid, maybe at most you'd be afraid because you just don't know how to do what you want to do at all, right? But you're not afraid of making changes because you don't have any reason to fear those changes. You haven't, right? And then as you learn more, you actually, I think, become more afraid because now you've gotten burned in situations. You've made code that then was brittle and you couldn't change it, and it was all a disaster, and it was too slow, or who knows what happened, right? Or you've heard a bunch of lectures with people getting up saying all these things about what's good code and what's bad code, and oh, you didn't have a overloaded equals operator in your private section of your class, and you're a bad person, and all this other stuff, right? And your head's all mixed up about stuff like that because you don't really know what to believe, and you don't have enough experience yet to really get to the point where you're certain about what's right and what's wrong in terms of your programming practices. So you're kind of mixed up, and it becomes fairly fearful. And I think an important part of getting to be a good programmer is getting past that stage to the point where you're comfortable letting design emerge and letting good code emerge through series of refinements, right? And respecting the fact that good code is code that works well, is easy to change, doesn't have a lot of bugs in it. That's what's good code, not some arbitrary set of things you're afraid about doing or not doing. Right? And getting to that point is difficult, right? Because it requires enough experience with programming to be comfortable with programming, the act, and being confident that you can spend time to work on code, relax, know that you're going to take a week or two to do something, that you know how to break it down, you're not scared about what's going to happen when you start down a path, because you know either the path will materialize or it won't, and you'll be able to tell that it's not and back up, right? And getting to that point is difficult. I don't think there's a magic bullet. That's just part of being good at your job by having done it. And by also, in some sense, rejecting the notions that there's these golden rules to programming that are about specific code. Because really, as far as I'm concerned, that's not true. The only golden rules to programming are focusing on those results, right? Golden rules to programming are about how you go about your mental act of programming, not about what the code actually looks like, because not only does what the code looks like and what's the right code, I think, vary from programmer to programmer, because different programmers work in different ways. But also, I think it's the case that any rule you might come up with, there are probably very good cases for breaking that rule, right? If the rule is about specific things in your code, you know. And so I think it is difficult. Doing large design work and large systems work is difficult. And operating on the level we operate on Handmade Hero is difficult, right? Keeping this whole architecture. If you think about how much fungibility there's been, how many changes we made in Handmade Hero, how many systems are interacting, and how we've kept that all under control, and we've never really had a problem keeping our game running and going through these changes. Yet that's hard, right? And since I've done so much programming in my lifetime, I'm able to keep that sort of thing under control. It's not a given that you can do that when you're first starting out. I wouldn't have been able to do that maybe in my first couple years of programming, right? Because I just wouldn't have had the experience to make sure that I had the good sense to not go down really bad paths and not put the code in really brittle positions, right? So that's just about gaining experience. And unfortunately, I really don't think there's anything anyone can tell you up front that makes you suddenly get there. But you can, but the good thing to tell you and to internalize is just that you can get there. And that getting there is about trusting the outcome of the code and believing what you see when you work, right? Seeing how code works and seeing what produces good results for you and believing in that is much more important than watching a bunch of experts tell you something about what the right code looks like, because that's just not so useful at the end of the day, right? Those things are really not what to focus on, right? And you'll notice I try not to do that very often on Handmade Arrow in general, right? I very rarely try to say, when you write this piece of code, it should look exactly like this, because that's just not really interesting. And you will come up with those as you become a better programmer. You will come up with your own hard and fast rules for certain things that you find are always good for you, and that may be true. But it won't necessarily be true for other programmers, because those rules are usually about compensating for some shortcoming you have that makes it so you don't make mistakes. And I do those for me, like all of my hard and fast rules that I have are about making sure that I don't have bugs in ways that I myself often accidentally make those bugs, right? And so another programmer's brain isn't going to have the same propensity for the same bugs. They're going to have a propensity for different kinds of bugs. So the sorts of things that they do that are hard and fast rules for them are about compensating for their shortcomings, right? And so if I tell them these rules about how to compensate for my shortcomings, it may just be wasting their time, because all they're doing now is guarding against bugs that I would make. But they may never make those bugs, right? And same thing with the design. If there's certain aspects of the design that always kind of are problematic for you, and so you make these rules about design that keep you out of those traps, great. But those may not be the traps that I would fall into, so I don't need to obey those design rules, right? And so I think that's sort of the problem. You know, at the end of the day, it's all just machine code. And any machine code that executes and produces the right result in a reasonable amount of time is good code. End of story. And what the source code looked like, and pretending that somehow you can look at that and assign some objective measure to whether that code was good or bad, I just don't believe that, because I fully believe that who the programmers are that need to work on that code largely determines what that code needs to look like to be good, right? Because what it means to be good code for them may be very different than what it means to be good code for another team, because the things that they do and how they work, the code is amenable to it or it isn't. And you know, somebody who writes a book that says this is what good code is, it's just simply not true if you then take that same stuff that's supposedly good code and give it to programmers who program in a very different way. All of a sudden, all of the things that code was assuming that it needed to guard against for bugs, and that it assumed it needed to be flexible and modifiable by these programmers, is not true anymore. Because these programs over here, they program in a different way, they have a different methodology, they make different kinds of mistakes more frequently, and different kinds of mistakes less frequently than this other team. And so I think that's very important to understand, and it's a very important part of becoming a good programmer, is understanding that, and understanding that that's what makes good code is contextual, not absolute, if that makes sense. The only absolute metrics of good code is, did it perform correctly when executed, you know, didn't have a bug, and was it efficient? Those are the only objective metrics we have for good code. And so all the other things that don't have effect on that, like const or putting things in the private section of a class, these things have no effect in the vast majority of cases on those objective metrics. So they are about whether the programmers on the team need these things to be efficient and work well, not about whether the code is in an objective sense good, because they don't affect the objective measures of the code. All right, let me take one more question here. Let's make sure it's a hard-hitting question with a lot of content to it. Well, actually, here's one that I'll answer really quickly. I keep missing the pre-stream, so at what time tomorrow will it start? Basically, the schedule is pretty much always right. So if you go to here and click on ScheduleBot, This tells you pretty clearly. The pre-stream generally starts at the broadcast time. Sometimes it'll start 15 minutes early, but the most it'll ever start is 15 minutes early. And usually it starts right around the time it's supposed to start. So, if it says 10 a.m., the pre-stream starts at 10 a.m. Sometimes it'll start at 9:45, but that's the very earliest it will start. And if you're if you follow me on Twitch, if you follow Handmade Hero on Twitch, it sends you an email in theory when I go live as well. So it's supposed to be. Okay, so let's take a really important question here. How often do you clean your garage? If you don't have a garage, where do you park your car? If you don't have a car, how do you get to Kansas? And the answer there is I do not have a car. If I did have a car, I would not have to clean the garage anyway because I live in an apartment building which has a shared garage, which is cleaned by the maintenance people for the building. And it's like this giant industrial garage, right? So it's not like I can't store anything in it either. Usually when you think of cleaning the garage, you've got all this, like, my rake and my trash barrel, my lawnmower or whatever. You're not allowed to store your own personal junk in the building's garage anyway, so there's not much cleaning. The only thing they ever do is the maintenance staff power washes it down at some point, I think, to get like the dirt. And that's once every couple of months or a year or something like that anyway. So almost nobody really cleans the garage in really the same sense anyway. Without a car, how I would get to Kansas is I would fly. But that is how I would get to Kansas even if I didn't have a car. I mean, if I did have a car, because it's a really long drive to Kansas. I feel like, if you were going to go to Kansas from here via a car, guess I don't know where in Kansas, what city we're talking about. But there's the driving, I guess. And you would be driving for an entire day with no sleep. So probably 2 days if we're realistic to get there. So I feel like I would not do that. I do obviously know that sometimes the fastest way to get to Kansas is to click your heels together if you have red ruby slippers. I don't have red ruby slippers, so returning to Kansas via magic is not an option that I have available to me. But I obviously would encourage people who do have magic slippers to use that because it is cheaper than airfare, and And Popcorn OX90, yes, John and Casey are in the same city for the moment. John, though, is not in Seattle full-time. He's up here only part of the time. So whether or not we're in the same city is kind of, it depends, I guess is what I'd say. Depends on the month or the week. Alrighty then. Let's close it down. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. I am pleased to see the code getting simplified now that we are working on the 3D transition. I feel like that really kind of keeps things a little bit more under control now that we're sort of unifying that pipeline. So that's making me happy. That's why I want to do it. And it looks like it is going exactly the way I'd hoped, so that's good. And getting rid of that nexus of sprite sorting makes me happy too, because I just didn't have a lot of confidence in it. I didn't like it. It was too much code executing in a too crucial part of the pipeline in a place that doesn't scale well because it's where you push sprites through. And I really just didn't like that and didn't make me comfortable. So I'm happy that we're moving away from that. And I think it's, yeah, I'm much happier about that. I think there's going to be a lot of really good things to come out of that. We will continue down that path tomorrow. We'll get rid of the sorting code, and we'll sort of start to solidify that clip-rect stuff in a sort of more efficient way as well. You'll see how we'll do that. I think there's some pretty good ways we can make that happen and start to clean things up more. So that's that. I hope you'll join me for that. That's tomorrow, 10 a.m., same time, same place. That's Pacific Standard Time for those of you in other time zones. That's about it for today. Yeah. If you would like to follow along at home, of course, at handmadehero.org, you can pre-order the game, and it comes with the source code. So if you want to follow along at home, you can do that. We also have the forum site you can go to ask questions, a Patreon page if you want to support the video series. We've got a schedule bot you can go to if you want to know when we're going to be live, and a fantastic episode guide maintained by Miblo. You may have seen him on the chat. And yeah, if you're trying to catch up on old stuff, that's a great place to go. There's also a great search engine that Asaf Gartner made. I don't actually know when that's going to be. Do we know? Does anyone, Miblo? Do you know when that really nice episode guide search feature is going to be sort of fully rolled out? I'm assuming. I mean, is that going to get rolled into the episode guide at some point proper? Because it's pretty amazing. It's really, really good, and it leverages all those annotations that you made in a really great way, and I just don't know when that's getting what the plan is for that. I can show you where it is here. It's oops, I missed an IO. That's what I meant to type. So yeah, I don't know what the plan is for this or what's going on with it, but if you take a look here, Miblo does these fantastic annotations here in the episode guide, but you can't really use them as effectively if you don't know what day you're looking at. If you do know what day you're looking at, you can go here, and it's pretty efficient, right? You've got all the things here, and you can jump to any one. But if you don't really know what you're looking for, it becomes difficult. But with this thing, it's pretty cool. You can just type in what you're looking for, and you can see all of Miblo's annotations that match what you've typed in. And so when you come in here, you can jump to one of them, and then it'll show you right in line with the video, actually. And as the video plays, it actually shows you how far it is through that thing as well. And you can actually jump to specific times. It's a pretty great feature, and the UI is designed really well too. So yeah, Asaf did an amazing job on that. And I don't know when that's coming. You can access it early here by going to that URL. Let me see what Miblo has to say on the chat. Miblo says, yeah, we will roll it into the new annotation system, planning on working on the new system probably in a month from now after Handmade Network version 1 is settled. Yeah, so that's pretty great. That'll be kind of moving into the annotation system, I guess, over time. It's pretty amazing. So I would recommend checking that out if you haven't yet. Eventually, it'll just be rolled into this button where that goes. It'll have it, but it's pretty great. Oh, hey, and it's on the chat too. So thank you very much for building that. That's pretty great. Yeah. All right. Anyway, I'll be back here tomorrow for some more of the 3D coding. Hope to see everyone here for that. Until then, have fun programming yourselves, and I will see you on the internet. Take it easy, everybody.